Good afternoon, everyone. Welcome to the class on operation research, where we are discussing the previous year questions which came for the BCA operation research subject for the fourth sem student. So, when we talk about simplex method, definitely in exam, you will get a 6 marks problem. That is 100% for sure. So, in today class, we'll discuss this problem, which has came in 2018 for 6 marks. So, in the year 2018 for 6 marks we'll do this problem now. Okay, so I hope you will understand the concept of simplex method from this tutorial, and ultimately that will help you during your exam time. So you know that how to solve this problem by using graphical method. You know this very well. If you have two variable, you can easily apply graphical method and you will get the answer. Okay, so graphical method will work definitely on two variable. So right now, I will not go into graphical method to find the solution of this problem. Okay, so but you can remember that method would be one of the approach which definitely will help you to solve the problem. So this problem which came in 2018 for 6 marks, 2018 for 6 marks, will discuss problem with you people. So you can simultaneously you can solve this problem by graphical method or by solver. It is a function in MS Excel. Regarding graphical method, regarding solver, already I have communicated to you how you can use solver or graphical method to get the answer for the problem. Right now in this class, we'll discuss how you can solve this problem by using simplex method. So simplex method will give you always the solution for all kind of problems. So only thing when we work on simplex method, so whenever we are working on simplex method, few points you should keep in your mind. Whenever you are working on a simplex method, you should always make sure your objective function should be maxima. Okay, few things simplex method works when we talk about simplex method. So it works when the objective function, when your objective function is maxima. It works when your objective function is maxima. So your objective function should be maxima. Okay, then only the simplex method will work. And the next thing is that the constraints what we have, the constraint will have linear inequality, right? So the constraint must be, your constraint must be of less than or equal to sign. The constraint must be of less than or equal to sign. Your constraint must be of less than or equal to sign. Okay, so if you have greater than or equal to sign constraint, then the same kind of problem will solve by using big M method. So you can see the next question here, big M method. So they are expecting us to solve this problem by big M method. So after I finish simplex method, I'll teach you big M method. So how a big M method is being used, all that we'll discuss. Okay, right now we are not discussing about big M method. Right now we'll discuss about simplex method. In case of simplex method, your objective function should always be maxima, and the constraint what you're seeing in the simplex method, this should be of less than or equal to. Okay, so that point you need to keep in your mind while solving the problem. Your constraint should be less than or equal to. So once you know that your constraints are there in the form of less than or equal to, and your objective function and your objective function, when you're seeing the objective function, that is in the form of maxima. In case if your objective function is in the form of minima, suppose if your objective function is there in the form of minima, like minima of z is equal to 3x1 plus 2x2. So minima function you can convert maxima function by changing its sign. So you could have written this maxima of z is equal to minus 3x1 minus 2x2. So that way you can convert the objective function uh, into maxima function. Okay, so that you can remember. Okay, so I don't think so. Whenever there's simplex method problem, if it comes in exam, they will give you where the objective function is minima. Okay, simplex method problem, whenever you will get always when the objective function is maxima only. Anyway, we will not discuss more about this. Now coming to the question, when we talk to the question, whenever you are solving the problem by simplex method, okay, so whenever I'm solving the problem by simplex method, Let me just write down the problem. Here you have to maximize the z, where z is equal to 3x1 plus 2x2. Fine. And constraints you have subject to constraints. Subject to constraints. Subject to constraint. You have constraint like x1 plus x2 is less than or equal to 4. Then x1 minus x2 is less than or equal to 2. And then your x1 and your x2 greater than or equal to 0. So that is your objective function, guys. This is your objective function. Now what you will do, now in order to solve this equation, you need to convert the linear inequality of the constraint into linear equation, like the way how we used to do in graphical method also. You have to convert the linear inequality into linear equation. There we used to assume, okay, there what we used to do in graphical method, although the sign is less than or greater than and all, we for the time being we used to assume that okay fine, let it be equal to, and then we used to plot the graph, and then we used to consider the area. Okay, so here we will not do like that. Here algebraically will work here. So what you do, look into the constraint, look into the number of constraints, how many constraints you have. Okay, how many constraints you have. Now based on the constraint, what you do, you will introduce slack variable, or we call them dummy variable. So what we will do, introducing slack variable, introducing slack variables. Okay, so you can S1, S2, you can introduce any symbols like A1, A2, M1, M2, anything you can write, X1, X2, or X3, X4, something. So introducing X1, S2 slack variable and converting the problem and converting the given problem in standard form, and converting the given problem in standard form. We'll write like this, converting the given problem in a standard form. So what I'll do, I'll introduce slack variable S1 and S2. The, the purpose of introducing this slack variable S1, S2 is to convert the linear inequality of constraint as a linear equation. So that is the objective. And then the altogether the structure what you use to write down the problem, that we call is standard form. So if you try to write them in standard form, then your objective function will be maximum of z is equal to 3x1 plus 2x2 plus 0s1 plus 0s2. Okay, and subject to your constraints, subject to here you will write x1 plus x2 plus s1 is equal to 4, and then x1 minus x2 plus s2 is equal to 2. Okay, where x1, x2, s1, s2, they should be greater than or equal to 0. So what you are trying to do, you have introduced the slack variable, whatever the number of constraints you have, whatever the number of constraints you have in the equation, that many number of slack variable you will introduce in the problem, in the equation of constraint. Why? What are these slack variables? These slack variables actually dummy variables. Okay. So then why you introduce them in the equation? Because I want to convert this linear inequation of the constraint as a linear equation. So I introduced a variable called S1. You know that if to make you understand this, please understand. If I talk about this, this is x1 plus x2. So two things can happen with x1 plus x2. Either they can be equal to 4, either they are equal to 4, or either they would be less than 4. Okay. So if x1 plus x2 is less than or equal to 4, then two things can happen, that x1 plus x2, it can be equal to 4 or it can be less than 4. So if x1 plus x2 is equal to 4, then your dummy variable s1 would be 0. If x1 plus x2 is not equal to 4, then your dummy variable is the difference between the 4 and x1 plus x2. That will be your dummy variable, so that ultimately it become equal to 4. Suppose x1 plus x2 is 2, then slack variable will be 2. ultimately, so that the sum together we should become equal to 4. So the reason of introducing this slack variable, why we are introducing this slack variable, we introducing this slack variable to convert the linear inequation sign what we have into linear equation sign. So by converting the linear inequation sign into linear equation sign, ultimately we are trying to convert the given equation, we are trying to convert the given equation in the standard form. Okay, then we are trying to convert this into standard form. Now the same thing I can write as, now the same thing I can write as x1, x2, then s1, then s2. In the matrix form or in the algebraic form, I can write this. The coefficient of x1 is 1, the coefficient of x2 is 1, coefficient of s1 is 1, coefficient of s2 is 0, coefficient of x1 is 1, coefficient of x2 is minus 1, coefficient of s1 is 0, coefficient of s2 is 1. Okay, and then this in the algebraic form, we'll write it like this way: x1, x2, s1, s2. You have two variable decision variable x1 x2 and two slack variable s1 s2, and that will be equal to RHS. Your RHS is equal to 4 comma 3. You see this, we write them in algebraic form. Algebraic spelling can be wrong, you correct it if it's wrong. Okay, so we write them in algebraic form. Clear everyone? So this was your actual question. This was the actual question. Now we introduce two slack variable. Why we introduced two slack variable? Because there were two constraints in the equation. So after introducing the two slack variables, okay, ultimately I try to make the linear inequations of constraint as a linear equation. Okay, and then the same adjustment we'll do on the objective function. Okay, where we'll introduce these variables s1 s2 with zero coefficients. Okay, now once you're done with this, now I'll you can solve this problem by algebraic method, or you can solve it this problem by tabular method. So I prefer this problem by tabular method. So algebraic method I don't follow to solve this problem. Now what we'll do, we'll write them, solve this problem by using algebraic method. So now I'll try to solve this problem. Now solving the problem. Now I'll write step by step iteration table. So iteration table. I'll draw iteration table. I'll draw iteration table to find the optimal solution. So I'll try to work on the iteration table to find the optimal solution. To find the optimal solution. To find the I'll work on the iteration table so that I can find the optimal solution of the given problem. So we'll for the given problem. So we'll work on iteration tables. We'll draw iteration tables one by one so that we can ultimately find the solution for the problem. So in order to work on iteration table, you'll draw the iteration table like this. This is RHS. This is theta. Okay, here you'll write x1, s1, s2, all the variables. Okay, all the variables you write. Okay, what is the coefficient of x1, x2? So what is the coefficient of x1, x2? You can see the coefficients. You can see the coefficient, that is 3, 2, 0, 0. You can see the coefficient 3, 3, 2, 0, 0. Okay, okay. And then here what you will do to solve the problem, you will start solving the problem by introducing the slack variables which are s1 and s2. In the first iteration table, you introduce a slack variable S1 and S2, because ultimately you will try to replace all your slack variable with your decision variable so that you can find optimal solution for the problem. All these coefficients, what you wrote is 3, 2, 0, 0, we'll call this a CI. We'll call them as a CI. Okay. Now, if you see inside the first iteration table, what coefficients you write, you'll write the same value. You'll write this value. Okay, we'll write this coefficient. How you got this? So by this, you can see the coefficient. This is 1, this is 1, this is 1, this is 1, this is -1, this is 1. You can see the coefficient. So same thing, I'll write it here. The same thing, I'll write it here. You can see the coefficients from here. The same thing, I'll write it here. So if I write them here, so this is 1, then 1, S1 is 1, there's no H2 in first equation. Then X2 is 1, X2 is -1, S1 is 0, and S2 is 1. Okay, and the RHS are 4 and 2. The RHS are 4 and 2. So this is what given in the problem. Now what you do, first thing what we will do, first we'll find the ZI. First thing what we'll do, first we'll find the ZI. What is ZI? ZI is the sum product of these variables, like 0 into 1 plus 0 into 1. You will do 0 into 1 plus 0 into 1. You'll get 0. 0 into 1 plus 0 into -1. You'll get 0. Then 0 into 1, 0, 0 into 0, 0. So here everything will be 0, 0. Okay. Then what you find? You find Ci minus Zi. Ci minus Zi, 3 minus 0, 3, 2 minus 0, 2, 0 minus 0, 0, 0 minus 0, 0. Once you're done with the calculation of Ci minus Zi, so that we will follow, or will try to do this iteration table. We'll try to work on this iteration table. We'll try to keep solving this iteration table. We'll do till at that moment till the Ci minus Zi is either 0 or negative. Okay, so till that moment we'll keep solving this iteration table till Ci minus Zi is 0 or negative. So if they are not 0 negative, so we'll pick the highest Ci and minus Zi value. So you can see the highest Ci minus Zi value is 2. So 3. 3 correspond to x1. It means x1 now enter into the solution. So if x1 will enter into the solution, then x1 will definitely will replace either s1 or either s2 to determine which variable the x1 is gonna replace either s1 or either s2. For that, what we do, we find theta. What is theta? Theta is this. Whatever value you selected no here, the value, the corresponding value of x1, you divide it by RHS. So 4 divided by 1, that is 4. Okay, then it is 2 divided by 1, that is 2. So whichever is the theta value, whichever gives you the minimum theta value, whichever gives you the minimum theta value, that will tell you which variable is exiting. So which variable is exiting? So it means S2 is exiting. It means S2 is exiting because the minimum theta values of S2. So it means theta, it means the S2 will exit and S2 will be replaced by X1. Okay, and here this variable X1 is called as pivot element. This value S1, the value 1 which is corresponding, the value 1 which is corresponding to a row and column, the value 1 which is corresponding to the variable which is going in and the variable which is going out, that variable is called as pivot element. So here you will call 1 as the pivot element. Here you will call 1 as the pivot element. Okay. So now what we'll do? Now now that we are done with one iteration table, now you know that S1 will remain as S1 having 0. In place of S2, the X1 will come. X1 having the coefficient 3. Okay, the pivot element is 1. So divide everything by 1. 1 divided by 1, 1 divided by 1, 0 divided by 1, 1 divided by 1, and 2 divided by 1. Okay, now you got the value of x1, right? You got the value of x1. Now you have to find the value of s1. Now you have to find the value of s1. You got the value of x1, right? Now you have to find the value of s1. Now you have to find the value of s1. So how will you find the value of s1? So that also we do step by step 1 minute. Now to find the value of s1, how will I find the value of s1? So to find the value of s1, we follow a formula. We follow the formula. The what the formula says that. So here we'll write old element, then we'll write new element, and then the formula we follow to find the new value of s1, to find the new values of s1, to find the new values of s1, we follow the formula that is old element minus k into new element. Where what is k? K is called constant or the pivot element for that column or row. The pivot element for this row would be the corresponding value of that. With the selected range, what is the corresponding value? The another value that is k. That is k. K here is also one only. So old element means old values of S1. The old values of S1 is 11104. The old values of S1 is 11104. So what is new element? Any means new element. New element is basically the values which you wrote here. So this value what I wrote, the x1, which was your pivot row. So for that all the values what you wrote, we call this as a new element. 11012, 11012, 11012, and the k is a constant. K is here is 1. K here is 1. K here is 1. You can see the constant here. K here is 1. So 1 minus 1 into 1, that is 0. 1 minus 1 into 1, that is 0. 1 minus 1 into 0, that is 1. 0 minus 1 into 1, that is minus 1. Then this is 4 minus 2 into 1, this is 2. So the new value of S1 will be 00 00 112, 00 double 0 double 0 double 1 minus 1. Actually this is 1 minus 1, 00 1 minus 1 2. Now this will give you the value of S1. Okay, once you get this, now again you find the Zi. Once you get this, again you'll find the value of Zi. You'll again find the value of Zi. Zi would be 0 into 0 plus 3 into 1. That would be 3. 0 into 0 plus 3 into 1. This would be 3. 0 into 1 plus 3 into 0. 0. 0 into minus 1. 0. 3 into 1. 3. 0 into 2. 0. 3 into 2. 6. Now find Ci minus Zi. We'll keep doing this calculation till either we'll get negative or 0. Ci minus Zi, this is 3 minus 3, 0. This is 3 minus 3, 0. Then 2 minus 3, 2 minus 3 minus 1. One minute. So this is S1, 1 minus 1. Okay, this was minus 1. Sorry, this was minus 1. So because I write with yellow color, it become invisible. This is minus 1. So this is minus 1. This is minus 1. This is 1. So this would be 1 minus 1 into minus 1. So this would be 2. This would be 2. This would be 2, 0, 2, 1 minus 1 and 2. 0, 2, this would be 2, this would be 2, this would be 2, so this would be 2, this would be minus 3, this would be 2, this would be minus 3. So if this is minus 3, then 0, 0 minus minus 3, that would be 3. Okay, and this is 0, this is minus 3. Now if you see all the ci minus zi, if you see all the ci minus zi, you see, if you see your all your ci minus zi, so that should be either 0 or negative. To find the optimal solution, here you can see they are not 0, so it means this is not 0, means this correspond to x2, this correspond to x2. It means now x2 will enter into the solution. It means now x2 will enter into the solution. If x2 will enter into the solution, then this x2 will replace whom? That this x2 will replace whom? For that, I'll find the RHS. RHS value is given. We divide the RHS by this 2 divided by 2, 1, and 2 divided by minus 1 will not consider the negative value if you're getting. So if you're getting negative value, will not consider it. So you can say that the smallest value now is 1. This, because we will not consider this negative value. If you're getting, you not consider it. It means the S1 will go out and S1 will be replaced by X2, and the corresponding value of this, the point of intersection of row and column. So this corresponding value is called as pivot element. This corresponding value is called as pivot element. This corresponding value, we call this corresponding value as a pivot element. Okay, so pivot element. So now it means that S1 will be replaced by X2. Now it means that S1 will be replaced by X2. Once you realize that S1 will be replaced by X2, once you assume when you realize that S1 will be replaced by X2. Now what you do? Now again you just draw the iteration table again. Now again you will draw the iteration table. Again you will draw the iteration table. In place of S1 you will write X2 with coefficient 2, I guess, with coefficient 2. Okay, then you'll write X1 with coefficient 3. Now you know that 2 is your pivot element. So now to get the value of x2, divide all the elements of the row by 2. So 0 divided by 2, 0, 2 divided by 2, 1, 1 divided by 2, 1 by 2, minus 1 divided by 2, minus 1 by 2, 2 divided by 2, 1. Okay, now this by this I'll get the value of x2. This value of x2, what I got, this value I called as a new element. Okay, these values I'll call as a new element. Okay, this value, what I'll call this value as a new element. Once I call this value as a new element, okay, because x2 is the new values what you wrote. How you got that? You divide all the elements of the row, all the elements of that row by the pivot element. Once you get that, the now this value of x2, what you call, we call that as a new element, and the corresponding value of that pivot element is your k. This is your k constant. This is your k constant. This, and the corresponding value of x1, the old value of x1 would be called as old element. Now I have to find the value of x1. No, so I'll write the old element. What are the old elements? The old values of x1: 1 minus 1 0 1, 1 minus 1 0 1. So 1 minus 1 0 1 and 2. So these are the old element, and your constant is minus 1, and your constant is minus 1, and your new element, what is your new element? New element is the new values what you get of the new values what you get of x2, that is 0 1, 1 by 2 minus 1 by 2, 0 1, 1 by 2 minus 1 by 2, 0 1, 1 by 2, 0 1, 1 by 2 minus 1 by 2, and 1. So these we called as a new element. These we call them as a new element, where the constant for them where your constant for them is -1, where your constant for them is -1. Constant for them is -1. So you apply the formula old element minus -1, which is a constant new element. I can write then the formula old element plus new element. That is a formula. This is 1 minus 1 plus 1. That is 0. And this is 0. Okay, 0 plus 1 by 2. That is 1 by 2. This is 1 minus 1 by 2. This is 1 by 2. Okay, then 2 plus 1. This is 3. This would be the new values of x1. 1 0 1 by 2 1 by 2 3. This would be 1. This would be 1 0, then 1 by 2 1 by 2, and then 3. Once you get this, once you get this value, now I'll find the zi value. Zi value is 2 into 0 plus 3 into 1, then 2 into 1 plus 3 into 0, then 2 into 1 by 2 is 1, 3 by 2 1.5, 1.5 plus 1 2.5. Okay, then this is minus 1, 3 by 2 minus 1, so 1.5 minus 1, that would be 0.5. This is 2, 9 plus 2 11. Now I'll find Ci minus Zi. So the Ci minus Zi, if you find, see the corresponding one, 3200, you can see 3 minus 3 0, 2 minus 2 0, 0 minus 2.5 minus 2.5, 0 minus 0.5 0.5. So now you can see that all the values of Ci minus Zi, what you get, they are either positive, either they are 0 or either negative. It means now you got the optimal solution. Now it means that you got your optimal solution. So this is your optimal solution, guys. This is the optimal solution. You can see that. So what is your optimal solution? If you see your optimal solution, if you see your optimal solution, you can see, so your optimal solution. What is your optimal solution? You can see your optimal solution is x1 equal to 3 and x2 equal to 1, and your objective function is 11. This is your optimal solution. Ask me if anyone have any doubt. Anyone, any doubt, ask me. Anyone, any step you want me to discuss again, please ask me. Let's discuss another problem based on simplex method. Suppose this is the problem. Okay, so now again, what you will do here, you can see you have two constraints. So you'll introduce two slack variable into the equation. So introducing the two slack variable s1 and s2 and converting the equation in the standard form. So you can write English, introducing two slack variables, introducing two slack variables s1 and s2, introducing two slack variables s1 and s2, introducing the two slack variables s1 and s2, and converting the equation into standard form, and converting the equation to standard form, and converting the equation standard form and converting the equation into standard form. So what I can write maxima of z is equal to, okay, then I can write 6x1 plus 5x2, 6x1 plus 5x2 plus 0s1 plus 0s2. Okay, then subject to constraints, what all constraints you are subject to. Your constraints are, you can write x1 standard form, x1 plus x2 plus s1 is equal to 5, and then you can write x1 plus 3x1 plus 2x2, 3x1 plus 2x2 plus s2 is equal to 12. So where your x1, x2, s1, s2, they should be greater than or equal to 0. So you can write them like this. So now what you did, you converted them in a standard form by introducing the two slack variable s1 and s2. Okay, once you understood them to write them in the form of standard form, now what I'll do, I'll solve this equation by following iteration table. So construction of iteration table, construction of iteration table, iteration table. So I'll construct the iteration table here. I'll construct the iteration table here, x1, x2, then s1, and then s2. Then I'll write RHS, and then I'll write theta. Here the coefficients of x1, x2, s1, s2, we write it by looking at the objective function 6500. This is 6500. That is the this that is called CI. That values we called as CI. This value we called as CI. Okay. Then slack variable I'll introduce into the solution. We always start solving the equation by using this, by working on the slack variable. Now you can see the coefficients. This is 1, this is 1, this is 1, this is 1. So 1, 1, 1. You can see 1, 1, 1. S2 is 0 here. And this is 3, this is 2, this is 0. S1 is 0 here. There's no S1 in second equation. 0, 1. Okay. And then RHS would be this value. This value we call as RHS 5 and 12. So the first ZI, whatever you get, that will be 0 only. The first ZI, that will be 0 only. Okay. Then what you will do, you will find CI minus ZI. You will find CI minus ZI. That would be same like simple 6 minus 0, 5 minus 0, 0 minus 0, 0. So it means by looking at this CI minus ZI, the highest value is this. It means this is entering into the solution x1. And these values, you divide the RHS by this value, 5 divided by 1, 12 divided by 3. With this, you will find the value which is exiting the x1, which whom he is replacing. That would depend on the value which have minimum theta, means x1 is replacing s2. Okay, so x1 is replacing s2. So once you understood this, so here I'll write s1 0 coefficient, x1 with coefficient 6, and this value and the value. So the value which is corresponding to the row which is exiting and the column which is entering, that value is called pivot element. Okay, now what you do, divide all the element of this row by this pivot element. So 3 divided by 3, 1, 2 divided by 3, 2 by 3, 0 divided by 3, 0, 1 divided by 3, 1 by 3, 12 divided by 3, 4. Okay, so once you get this, okay, now what I'll do, I'll find the value of S1. Now I'll find the value of S1. How will you find the value of S1? So to find the value of S1, now I want the value of S1. X1 value I got, okay, by dividing all elements, all previous element of S2 by the pivot element. So that was 1, 2 by 3, 0, 1 by 3, 4. Now, what is old element? The old values of S1. The old values of S1, that is 1, 1, 1, 0, 5. And the constant for this calculation of S1 would be the corresponding value of that. That is 1 only here. That is 1 only here. So you will find old element minus and this new element. So here constant is 1 only. 1 minus 1 0. 1 minus 2 by 3 is 1 by 3. Okay, G1 minus 0 1. Then this is minus 1 by 3. And this is 5 minus 4 1. So 0 1 by 3 1. 0 1 by 3 0 1 by 3 1 0 1 by 3 1 0 1 by 3 1 minus 1 by 3 1 minus 1 by 3 1. So now I'll find Zi. Zi means some product. 0 into 0 plus 6 into 1. 0 into 1 by 3, 6 into 2 by 3, that would be 4. This is 0, this is 0, this is 2. Okay, this is 24. Okay, now what I'll do, I'll find Ci minus Zi. 6 minus 6, 0, 6 minus 6, 0, and then Ci for that was 5. So 5 minus 4, 1. This is 0, this is minus 2 by 2. It means this will enter into the solution. Okay, this means this will enter into the solution. It means x2 will enter into solution. It will replace what? For that 1 divided by 1 by 3, 3. 4 divided by 2 by 3, 6. So it means it will replace whom? It will replace S1. So x2 will replace S1 and the corresponding value of the column which is entering and the row which is exiting is called pivot element. Okay, now this is called pivot element. Pivot element here is S1. So here in place of S1 I'll write x2. Here that was earlier already x1 and the value of x1 coefficient was 6. The x2 coefficient would be 5. Okay, and then the 1 by 3 is pivot element, divide everything by 1 by 3. So that then it would be 3, then this would be minus 1, and then this would be 3. So once you get this, so this set of value, what you get, this set of value, what we get, we'll call this as a new element. And what is the old element? Old element for x1, you want the value, no? So old element will be the old value of x1. The old value of x1 is called as old element. So old values of x1, what are the old value of x1? The old value of x1 that we call as an old element. I'll call that as an old element. So old value of x1, that is 1 2 by 3, 1 2 by 3, 1 2 by 3, 0 1 by 3, 0 1 by 3, and then 4. Now what is the new element? The new values, what we got? The new values are 0 1 0 1 0 1 3 minus 1 3. And what is a constant here for this calculation of x1? What is constant here? What is the constant here? The constant what is the constant here? 2 by 3. The constant is 2 by 3. The constant is 2 by 3. So you can use the formula old element minus 2 by 3 of new element. So this is 1. This is 2 by 3 minus 2 by 3 means 0. So 0 minus 2 by 3 into 3. This is minus 2. Then 1 by 3 minus minus plus 1 by 3 into 2. 1 by 3 plus 2 by 9. 9 common. 3 plus 2, 5. 5 by 9. Okay, then last one is 4 minus 2 by 3 into 3. And it is 2. So you'll get 1, 0, minus 2, 1, and 2. One minute. This is 1 by 2 plus 2 by 3. That would be 1. 1 0. This would be 1 0 1 0 minus 2 1 0 minus 2 1 and 2. Now for this, I'll find the Zi. The Zi value would be 0, 0, then 0, 0. Then this is 15 minus 12, 3. 1 minute. 15 minus 12, 3. 15 minus 12, 3. Minus 5 plus 6, 1. 6, 1. 5 minus 1 minus 5 plus 6, 1. Then this is 15 plus 12, 27. So it means this is your, now if you find your Ci minus Zi, if you find your Ci minus Zi, so you will find that is minus 6. So minus 6, because the minus 6, minus 5, minus 3, minus 1. So if you observe that all your Ci minus Zi, okay, so all your Ci minus Zi, the values, if you see the values, 1 minute, so just 5 minus 0, 0, 6 minus, this will be 6, this will be 6. Okay, 5 minus 0 will 6 minus 1, it will be 6. 5 minus 1, 5 into 1, this would be 5. This would be 0. You can simply find this value. 5 into 0, 0, 6 into 1, 6. 5 into 1, 5. Okay, and 6 into 0, 0. This is 15 minus 12, 3. This is minus 5 plus 6, 1. This is 15 plus 12, 27. So 6 minus 6 would be 0. 5 minus 5, that would be 0. This would be minus 3. This would be minus 1. So if you see now, if you observe, all your Ci minus Zi is either 0 or either negative. So with this, you can easily say that, guys, with this, you can easily say that you get the optimal solution where your Zi is 27, which is the optimal solution. The maximum value of Z, what you get, the maximum value of Z, what you get, the maximum value of Z, what you get is 27, where your x1 is equal to 2 and your x2 is equal to 3. The same solution you would have got if you solve this problem by graphical method. So either you solve it by simplex method, or you solve by iteration table mechanism, or by algebraic method, or by graphical method, or by using the option solver option in MS Excel. With every way, you will get the same answer. So I hope you understood this. Anyone have any doubt, please ask me. Anyone want to ask any question? So, okay guys, so this much we'll do in today class, and so we'll discuss our concept further on problems on simplex method. Simplex method yet not over. We need to discuss lot on simplex method, which we'll do in next class. Anyone, any doubt, any question you want to ask from me? So I hope you understood, guys, whatever I've done. So I'll see you all tomorrow with new problems on iteration tables on simplex method, and we'll continue our discussion on that. Clear everyone? Anyone, any doubt? Okay, thank you everyone.